Hello and welcome to my YouTube channel. This is Dramani Online Math. If you know you have not subscribed, please help me to subscribe to my YouTube channel. Help me to grow it so that all the credit, the vandals, and the energy will not go at waste. Thank you very much. We are still on the tangent, okay? We are looking at a situation whereby you see the first ones that we saw. The points were given, and we are to find the tangent line. We are looking at a situation whereby the point is not given, but the equation of the line is rather given. Can you see what I'm trying to say? The equation of the line is given. So, for instance, find the equation of the tangent to the curve y equals x squared minus x minus 2 at the point where the curve meets the line y equals x plus 1. There's difference between a tangent and there's difference between when a line meets. Okay? Yes. The tangent is where the line touches the curve at only one point. And when the line meets could be, I can even have something like this, curve like this, and the line is meeting in this way. They have met, right? Yes. So where the line meets does not necessarily talks about the tangents. The tangents only happen when it touches only one point of the curve. Okay. So for this case, anytime you have something like this, you remember back in JHS, back in SHS, you were drawing a straight line, two lines, okay? Let's say y1 equals mx1 plus c. You have another line, y2 equals mx2 plus c, okay? These are two lines. If you have two lines like this, and you want to solve it algebraically, you can solve this simultaneously to get your maybe whether the x and y that you are looking for to get it your point. You can also draw these two lines on the graph, and you see that on the graph that two lines will intersect, and when they intersect you trace it depending wherever you want it to go to get your x and y from the graph. So anytime two lines meet, whether being a curve and a line or two straight line, when they meet to get their intersection algebraically, you can solve it with simultaneous equation or simultaneously. I hope you understand. Very good. So I'm going to start with this. We have my y equals x squared minus x minus 2, and also meeting this line y equals x plus 1. Now we have to find the equation of the tangent. So still we need to get a gradient. We need to have the points. So here the main reason why you are doing this to get the point x and y. Now if you name this one equation 1, equation 2, we have it like this. So what you are going to do here is that you solve this one simultaneously. So you realize that this y is equals to y. So you can say that y is equals to y. Is that okay? So what it means is that x squared minus x minus 2 should be equals to x plus 1. Or somebody can also say that let's put equation 2 into equation 1. Wherever we see y, we should put x plus 1. There is the same thing. So here, this will give us x squared minus x. This x can be, we have negative x, negative 2, negative 1 equals 0. So I have x squared minus 2x minus 3 equals 0. So this is quadratic equation. So we want two numbers such that when you multiply those two numbers, I'll get negative 3. When we add, you get negative 2. So these are the two numbers. negative 3 and what? 1, right? Negative 3 times 1 will give you negative 3. Negative 3 plus 1 will be negative 2. So negative 3x negative 3 equals 0. Here, if I factorize, okay, here plus x. Good. So this is what you are going to have. It should be negative 3 and positive 1. Good. So if I factorize x out here, I have x minus 3. And here too, x minus 3 equals 0. Since the one in the bracket are the same, this is what we do. We pick the outside one. X plus 1, x minus 3 equals 0. So x plus 1 equals 0, or x minus 3 equals 0. So I have x equals negative 1, or x equals what? 3. So these are the values of what? X. So you need to get the values of what? Y. Okay. So let's see this. Here, what it means here is that whatever that I put here, whether this one or this one, I have to get the same answer. Let's try negative 1. If you put negative 1 here, you have negative 1 squared, that's positive 1. Let's see. I just want to test if I put negative 1, whether in this or this, I'll get the same thing. Is that okay? So I have y equals negative 1 squared minus negative 1 minus 2. This will give you 0. Let's also put negative 1 here. See, y equals negative 1 plus 1. This will also give you 0. So what I'm trying to say is that it doesn't matter. You see, you have two equations here, but it doesn't matter wherever you place your x, whether in this or that, you get the same thing. Okay. So here, when you put x there, so you have to say that at x equals negative 1. Is that okay? Then you put it, I'm using this one. I don't want to suffer. Negative 1 plus 1. That's 0. So we have 1 point. Negative 1, 0. So that's when at x equals negative 1, y will be 0. Then also at x equals 3, what will be y? That will be y equals 3 plus 1, which is 4. So here to at x equals 3, y is 4. So these are the 2 points that we are going to use now. These are the 2 points, negative 1, 0, 3, 4. It means that you are going to have two equations of what? A line, or the equation of a tangent. You are going to get 2. So first one, let me clean everything then. You see that I've cleaned the equation of the line. I know the reason why. So these are the 2 points I'm going to use. You know why I've cleaned the equation of the line? Here, the line only helped us to get this point, okay? Where you have now getting to, we are interested in the tangent of the curve. So we are interested in this. So in the first place, we need to get the gradient, okay? So we need to differentiate this one. So this is dy dx is equals to 2x minus 1. So at x equals negative 1, what do we get? We are going to have dy dx is equals to 2 times negative 1 minus 1, which will give you negative 3. Is that okay? So my gradient, so let me name this one m1, is negative 3. That's at x equals negative 1. Let's also look at x equals what? 3. Then I will have dy dx to be equals to 2 multiplied by 3 minus 1. 2, 3 is 6 minus 1 will give you what? 5. So it means that my gradient will be what? 5. So these are the two gradients that we are going to use to get two equations of a line or the tangent. So one of them is 5. That's when at x equals 5. You see, I'm cleaning more because the question is too tedious. So let me take it this way. At x equals negative 1, the gradient was equals to what? Negative 3. And also at x equals 3. The gradient was equals to what? 5. So we are going to use these two. So take notes. So I'm going to start with the first point, okay, which is y minus y1 equals mx minus x1. So the first point is y minus. Now y here is 0. So I'm going to have 0 equals. Each gradient, we are using the first point, negative 1, 0. No, we had the gradient to go negative 3. So negative 3 x minus x1. Already this is negative 1. So meaning when you meet this negative, it become positive 1. So y minus 0 is 1 equals negative 3 times x is negative 3x. Negative 3 times 1 will be negative 3. Is that okay? Therefore, my y will be, my y, this one can become plus 3x plus 3 equals what? 0. So that is for the point negative 1, 0. Now let's look at the point 3, 4. You know that the gradient of that point is 5. So that one is going to be y minus y1 equals m x minus x1. So I have y minus y1 is 4, so 4 equals 5, that's the gradient. X minus 3, that is the x. So my y will be equals to 5 times s is 5x. This going to 5 times 3 is negative 15. So negative 15 plus 4, this goes, they become positive. So I have y equals 5x minus 11, right? So you can write y minus 5x plus 11 equals 0. So this one alone will give you 2 equation of the tangent. Is that okay? Please try your hands on the second one. You see how the first one is, you need to find simultaneous equation and go through a lot. Thank you very much for watching. Let's move to the next topic.